This is my Precalculus course. Today we're going to prepare for the second test. If you haven't done the homework completely incorrectly from the last class, do that homework before watching this video. I've said it before many times, math is a subject where you have to study at least 2 or 3 days before taking a test. But it doesn't matter how many times you tell students to study, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test right now together. And I'm going to give you a practice test for homework. And these tests are not only going to force you to do some studying, but they are also going to familiarize you with the format of the test so that you can't claim that you were caught off guard or that you were tricked. Now, if you want to get a really good score in the test, you're going to have to do more than just these practice tests. You're going to have to do every single problem that we did, or make sure you know how to do every single problem that we did in the last 9-10 classes. Everything from test 1 to test 2, and maybe even some things from the first part of the course. Hopefully these practice tests will ensure that you at least pass the test, but they won't guarantee that. And they certainly won't guarantee that you'll get an A or a B. So let's go ahead and take the first practice test. You can use a calculator, but I don't want you to use it for graphing. I want you to be able to graph without your calculator for this particular test. So you can use a calculator, just don't use it to graph anything. And I want you to try these problems on your own. Don't just watch me do them. So if you can do this problem, I want you to go ahead and attempt it on your own. And if you can't do it, that's okay. If you're a little rusty on some of this material, that's completely fine. But I want you to attempt it. I want you to attempt each problem first. And if you don't know how to do the problem, then that gives you valuable information. That tells you you have to study that particular topic. Don't just take the test in the next class because you won't know how to do the problems. So go ahead and attempt number 1. And when you come back, we'll do it together. Okay, we're back. So this is the standard form of the equation of an ellipse, because there's a plus sign here, so I know it's an ellipse. If these numbers were the same, then it would be a circle. And if this were a minus sign, it would be a hyperbola. And if one of these expressions were squared, but not the other one, then it would be a parabola. At least for these types of problems. So first we're going to find the center. The center is given to us with these yellow numbers here. So the center is -1, 1. So the center is right there. And if we square root this number, that's the horizontal distance that we move to get to the end of the ellipse at the right. And if we square root this number, well, let's go to the left first. We need this point. So 3 to the right and 3 to the left, and then if we square root this number, that tells us how far to go up and how far to go down from the center. So that's pretty much it. We do have to write the coordinates of the foci though, so let's not rush ahead. Now again, your ellipse doesn't have to be perfect, so don't spend a lot of time trying to draw the perfect ellipse. Now it's very difficult to remember how to find the focus, the foci. There's 2 of them. But if we draw a right triangle that goes from the center of the ellipse to wherever we think the focus would be, and then make a right triangle, we know that this length is half the length of the minor axis, and this length is c, which is always the distance from the center of the ellipse or the hyperbola to the focus. And of course, the hypotenuse must be a, because the hypotenuse is the distance from the center all the way to each vertex. It's this distance or this distance, they're the same. So the hypotenuse is half the distance, or half the length of the major axis. So that tells us what our equation is. A squared is equal to b squared plus c squared, and we know b is 2, we found that. We're looking for c, we know a is 3. So we got that information from there. We square rooted those numbers. And so if we solve for c, we get square root 5. So I'm going to come up with a different, I guess I'll use green. I'm going to come up with a different color. And root 5 is a little bit bigger than 2, so I'll be roughly there. Your location doesn't have to be perfect. So that's F1 and F2. Doesn't matter which number, which subscript, it goes where. And so let's write the coordinates. So when you write the coordinates of the foci, you start from the center. The center has an x value of -1. And then you have to move c units to the left. So we're starting from the center right here. Then you have to move c units to the left. So you have to subtract root 5, because root 5 is c. And then the y value is just 1. So that is that's F2. So we have one focus. Now F1, you're going to start from the same x value. The center is x value of the center is -1, but now you're going to plus root 5, add root 5, because you're going to the right. And the y value is 1 also. So these are the coordinates of the foci. So we graphed the equation and we wrote the coordinates of the foci. So if you got that right, good. Again, if you got stuck in a few places, that's okay. That's why we're doing these practice tests, is to get your mind started remembering this stuff so you can prepare for the test. But remember, this test is not going to guarantee that you're going to get an A on the test. It doesn't really even guarantee that you're going to pass a test. You need to look at all the other information that we learned to make sure that you pass the test. But again, these practice tests are going to ensure that you at least do some studying. Now, we have to find the value of these sums. And notice we have sigma notation. Now you see this up here, that's an infinity symbol. So that means that this is an infinite sum. And we can see just by the expression that this is going to be a geometric sequence. Now you can prove that by writing some of the terms. So we can plug in 3. And then we can plug in 4. Remember, it's just an ascending progression. And then we can plug in 5, and so on and so forth. So we have 1/2 squared, which is 1/4. And we have 1/2 to the 3rd power, which is 1/8. And 1/2 to the 4th power, which is 1/16. And so we can see that this is just a geometric sum, because we're just multiplying by 1/2 to get the next term. So now that we know it's a geometric sequence and we know it's an infinite series, we can use our formula. So the sum, the infinite sum, is equal to the first term over 1 minus r. You're going to have to memorize that formula. I know you don't want to, but you're going to have to. The first term we can see is 1/4. And r is a number that you're multiplying to get to the next number, so r is 1/2. And that's just going to become a complex fraction there. So 1 minus 1/2 is 1/2, and then we have 1/4 divided by 1/2. 1/4 divided by 1/2, which is obviously 1/2. Remember, you flip the divisor and change to multiplication, and you get 1/2. Alright, so if you got that right, good job. Try this part 2 if you haven't already done that. When you come back, we'll do it together. Okay, we're back. So we're going to plug in 1 and then 2. And by the way, we can use the formula. This is actually another geometric. It's another geometric series. So we can use a formula for the sum of the first n terms of a geometric series. You could do that if you want. That formula would be a1 times 1 minus r to the n over 1 minus r. You could use this, but there's not a lot of terms, so we can just do it manually. And remember, you can use your calculator in this on this test, as long as you don't use it for graphing. So add up all those numbers and we get 120. So if you got that right, excellent. So again, this is the special situation where we had an infinite series. Not all of them are going to be infinite, because here we had a series that was not infinite. Okay, so why don't you try number 3, and when you come back, we'll do it together. Okay, we're back. So we have a negative symbol here, which means that this is going to be a hyperbola. And we also see that the term with y comes before the subtraction symbol. It's before the subtraction symbol, so that means that the parabola is going to be going up and down. The parabolas are going to open up and down. So let's find the center. We're going to rewrite this as y minus 0, just so you can see what's happening here. You don't have to do this, but in case you forgot, this means that the center of the hyperbola is 2 and 2, 0. So let's graph that. That'd be about here. And now this here, if we square root that, that's the vertical movement from the center. So that's 1, 2, 3, 4, 5. If we square root 25. So we're going to go in this same number of units in the other direction. And then if you square root this number, which is non-existent, it looks like it's not there, but it's actually 1. If you square root 1, then you get the horizontal movement. So we have a point there and a point there. That's the distance we move from the center in both directions. So now we're going to draw our box. Now remember, the box is not part of the graph. The box is just to help us draw the graph, and a lot of students they're kind of annoyed by that box. But but you have to, well, you don't have to, but it makes it easier for us to draw the graph. So using this box, we're going to draw the asymptotes. And again, the asymptotes, like the box, they help us to graph the hyperbola. So we haven't graphed the hyperbola yet. And I just noticed we're supposed to draw dotted lines for the asymptote. So I'm going to redraw that. And then we'll draw the other asymptote using the corners of the box to help us. And then we're ready to actually draw the hyperbola. Now again, the hyperbola is opening up and down because y comes first over here before the subtraction symbol. Now these orange points are the vertices of the parabolas, because remember, a hyperbola is two parabolas. So there's one parabola and another parabola, and the dotted lines, the green dotted lines, just help us to see where the parabola is approaching as it goes up or down. So that is the graph. Now we just have to find the equations. Well, we have to find the foci. So again, if you have trouble remembering the equation to find the foci, what you can do is draw a purple right triangle like this. And this distance down here, that's always B. And this distance here is A, the distance from the center of the ellipse or hyperbola in this case. The distance from the center to a vertex is always A. So that means that the hypotenuse must be C. C is the distance from the center all the way to the focus. That's the way it is for ellipses and hyperbolas. So that means that our equation is the same as the Pythagorean theorem. A squared plus B squared is equal to C squared. So what we're doing now is we're trying to find the foci. And let's plug in our numbers. So A is 5 and B is 1, and so C is root 26. So now we're going to start from the center to find the coordinates of the foci. We're going to start from the center, and we have our x value is 2 and our y value is 0, but we're going to add root 26 to get to our focus, which is up here. Now we have to mark the foci so we kind of have an idea of where they are. So there's one focus. Here's another focus. So this is focus 1. And to find the coordinates of focus 2, we have the same x value, but we're going to subtract root 26 to go in the opposite direction. Again, from the center of the hyperbola down. So we start with a y value of 0, then we subtract root 26. So the final coordinates will be 2 comma root 26 and 2 comma negative root 26. So those are the foci, and point slope form is the form that I'm going to use for the asymptotes. And we have a point that's on both of the green asymptotes. that point is the center of the hyperbola. So the point that we're going to use is 2, 0. So I'm going to plug in 0 for yp, and the slope is the slope of that purple triangle, so that's 5 over 1. 5 over 1. That's the slope of this dotted line here, that asymptote. So 5 over 1 times x minus the x value of the point. So if we simplify that, well, we don't really need to simplify it, but I'm going to go ahead and just simplify it. We end up with that equation. And we're going to plug in the same point, but now we have a negative slope because now we're talking about the other asymptote, which is going down 5 units for every 1 unit. So that would be -5 times x minus 2. So again, we're using the same yellow and blue coordinates. Whoops. That should be yellow. That should be blue, and then we can just simplify, and we've got -5x plus 10. So those are the equations of the asymptotes. We have the coordinates of the foci, and we have the graph of the hyperbola. So if you got that right, excellent. Okay, so now it says write an equation of the graph below. P is a point on the parabola, and V is the vertex. So go ahead and try this problem. When you come back, we'll do it together. Okay, we're back. So first, let's write the coordinates of the vertex. So that'd be -3, -1. And the point is -6, +1. And we're going to use the vertex form of the equation of a parabola. That's just the easiest form to use when doing these types of problems. When you want to find the equation of a parabola and you're given a point in the vertex, we can use this. So we have the y value of a point, and we have the y value of the vertex, and we have the x value of a point, and we have the x value of the vertex. So we need to plug in that information to solve for the unknown, which is that constant a. So 1 plus 1 is 2, that's a double negative. And we have -6 plus 3 squared. You don't have to show all these steps, but then we have -3 squared, so 2 is equal to 9a, and a is equal to 2/9. So let's see if we can find some more room. So a is equal to 2/9, and now we just have to write the final form of the equation of the parabola. So we just write y minus the y value of the vertex, so that's a double negative, that will become positive, is equal to 2/9, that's the a value, times x minus the x value of the vertex, which is a negative, so it'll become a double negative, and there is the equation. Okay, so if you got that right, excellent. Okay, go ahead and try number 5, and when you come back, we'll do it together. Okay, we're back. So let's start plotting some points here. So we have a focus at 0, -2, and we have another focus at 4, -2. So those are foci. And we have a vertex at 3, -2. So it looks like our hyperbola is going to be something like this. So we can see the center. The center is that yellow area there. So I'm going to write C for center, and then I'm going to write 2, -2, so I don't forget that. Now we can see that the distance from the center to a vertex is 1. So that means A is 1. And we can see that the distance from the center to a focus is 2. So that means that C is equal to 2. Remember, C is always the distance from the center to the focus, and I'm going to spell out center so it doesn't confuse us. I don't want to confuse that C with the other C. Okay, so remember, we recalled up here that for a hyperbola we use this this red formula. You see that red formula? For a hyperbola, it's a squared plus b squared equals c squared. And we know this is a hyperbola because they told us. So a squared plus b squared is equal to c squared. So a is 1, b we don't know, and c is 2. So b would be equal to the square root of 3. So now we pretty much have everything that we need to write the equation. We're supposed to write the equation, it says up here, of the hyperbola, and we're also supposed to graph it. This is just a temporary graph. I would recommend just drawing the basic shape of the graph so you don't forget what the information is that we're given. So now let's write the equation. So we know that x is going to come first. So x minus 2, and I got that 2 from there, squared, and a is 1, so over 1 squared, minus, and I know that the x comes first because the parabolas are opening to the left and to the right, because the foci and the vertices of the parabola are they're on a horizontal line, being here. And so then we have y plus 2 squared, and I got that 2 from here. And that's going to be over root 3 squared. Now again, these signs are different because remember, the equation tells us to subtract. And maybe it would be best if I actually showed that. I don't think I need to show that. But we can show the double negative if you want, just to be thorough. So then when we simplify, and by the way, that's equal to 1. Don't forget the 1 there. In standard form, hyperbolas and ellipses are always equal to 1. So we have x minus 2 squared minus y plus 2 squared over 3 is equal to 1. And that is the equation. So we've got our equation. Now we just have to graph. So we're going to have to draw our box, and I think we used the pink color for the box last time, so we'll stay consistent. So we're going to start at the center and move up root 3. Root 3, if we do that on our calculator, push the blue second button if you're using a TI-84 Plus, the blue second button at the upper left, and then push the x squared button at the middle left, and then enter 3, and then press the enter button at the bottom right. We get 1.73. So that would mean that we move up 1.73 and down 1.73 from the center of the parabola, and we can then make our box. So that box wasn't exactly easy to see there. I'm going to make it a little, make the dotted line a little easier to see. That's kind of a weird looking box, but that's basically what it looks like. And these points here will make purple, and then we'll make the asymptote lines green, because that's what we did before. Okay, and then we'll make the actual graph orange. So these orange points are the vertices of the hyperbolas. So the hyperbolas are going to look something like that. Your graph doesn't have to be perfect, like I've said many times. It doesn't have to be perfect. So again, the pink box and the green lines, they're not part of the graph. They're just there to help you graph the parabolas. Now, it doesn't say to find the coordinates of the foci, so we don't need to do that. So if you got that right, excellent. Okay, now we're moving on to number 6. Go ahead and try number 6. And when you come back, we'll do it together. Okay, we're back. So the first thing we need to do is put the x's together and the y's together. And I'm also going to take that 139 and put it on the other side. Then I'm going to factor out 36 from these two terms here. And I'm also going to leave a space open there. Well, I guess I'll come back to that later. I'm not going to leave a space right now. Just going to keep things simple. So we factored out a 5 from these two terms. And now I'm going to do what's called completing the square. And the reason we're going to do this is we want to put this equation in a form that will allow us to graph. we can't graph the equation like this. It's not easy to do. So I'm going to add a special number, and I get that special number by dividing this number by 2 and then squaring it. So negative 2 divided by 2 is negative 1, negative 1 squared is 1, so I'm going to add 1. Now over here I'm going to do the same thing because that's the same number there, so I'm going to add 1. Now you might be tempted to add 1 here and add 1 here. Well, that's not correct, because we didn't really add 1 on the left side twice. What we did is we added 36 times 1, and we added 5 times 1, so we have to add 36 to the right side of the equation and 5. So these are now perfect squares, so that enables us to factor what two numbers multiply to 1 and add up to negative 2. Well, that's just going to be negative 1 and negative 1. And then 139 plus 36 plus 5 is 180. Now we can put these expressions into exponential form, and it's okay to skip some of these steps. You don't have to do every one of these steps, but you do need to show some work, so don't think that you can just use the internet or something. When you're doing this test, you should have nothing in front of you except a paper and pen and calculator. I mean, when you actually take the test in the next class. So now we're going to, we need to get 1 over here. We need to make this number 1. That's the standard form. So we need to divide both sides of this equation by 180. So I'm going to do that. And when you divide both sides by 180, this side becomes x minus 1 squared over 5, and this side becomes y minus 1 squared over 36, and this side becomes 1. Because if you reduce the fraction, 180 divided by 5 is 36, and 180 divided by 36 is 5. So if you reduce this fraction, you get 1/5. And if you reduce this fraction, you get 1/36. So now we're ready to graph. We couldn't graph in this purple form up here, but we can now graph in this blue form. So yes, we had to do all that math just to get to the point where we could see how to graph this equation. Now you'll notice that this is an ellipse because these two numbers are different and we have an addition sign. So it must be an ellipse. If we had a subtraction sign, it would be a hyperbola. And if these two numbers are the same and it was an addition sign, then we would be dealing with a circle. So let's graph the center. We have 1, 1. Remember, you switch the signs. So 1, 1. That's the center of the ellipse. And then we're going to move up 6 units. 1, 2, 3, 4, 5, 6. Because we square root that number to see the vertical movement from the center of the ellipse. Then we're going to move down 1, 2, 3, 4, 5, 6. And then we're going to square root this number, and that's going to be a little bit bigger than 2. So move out a little bit bigger than 2 to the right, and move out a little bit bigger than 2 to the left. So then we're ready to connect the dots. So we have our ellipse. And it tells us to graph the equation, and that's pretty much all it really tells us to do. So this is our answer. We don't even have to rectangle this because it's not part of our answer. Okay, so if you got that right, excellent. Alright, so this problem says graph the following equation. Try number 7. When you come back, we'll do it together. Alright, so the first thing that we need to do is put the x's together and the y's, and I'm going to put the 3 on the other side of the equation. Then we need to complete the square for each expression. So I'm going to take this number, divide by 2, and then square it, and then add that. And I'm going to take this number, divide by 2, and square it, and add that. And I didn't have to factor because there was no coefficient on x squared or y squared. In the previous problem, we had coefficients. See the blue 36 and the blue 5, so we had to factor out. But in the problem we're doing now, there's no coefficients on the variables that are squared. See this here? There's no coefficients. So now we added 4 and 9 to the left side of the equation, which means that we have to add it on the right side of the equation. Alright, so adding all these numbers up over here, we have 16. And we're going to complete the square here. And we have x plus 2 times x plus 2, or actually we already completed the square, we're just factoring actually. So y minus 3 times y minus 3. So we're asking what number times itself, or what two numbers multiply to 4 and then add up to 4. That's 2 and 2. What two numbers multiply to 9 and add up to -6? Well, that's -3 and -3. Because these two blue factors are the same, and because the two green factors are the same, each one of those expressions is going to be a perfect square. So we have x plus 2 squared plus y minus 3 squared is equal to 16. So if you remember your standard form of a circle, here's the standard form of a circle, which means that the center of the circle is -2, 3. So 1, 2, 1, 2, 3. And the radius of the circle is the square root of this number, so that would be 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we just have to draw the circle. Again, it doesn't have to be a perfect circle. It just has to look roughly like a circle. So we graph the equation. So if you got that right, excellent. Okay, let's go on to number 8. Go ahead and attempt number 8. And when you come back, we'll do it together. Okay, we're back. So if we want to find a particular term in an arithmetic sequence, we have a formula for that, and you're going to be required to remember all these formulas. We have the nth term of an arithmetic sequence and the nth term of a geometric sequence. We have the sum of the first n terms of an arithmetic sequence, and we have the sum of the first n terms of a geometric sequence. You have to memorize all 4 of those formulas, whether you like it or not. Also, you need to memorize the formula for an infinite geometric series. So that's this formula down here. So you have to memorize at least 5 formulas, at least. There may be more, you have to check. So, we're trying to find the 75th term, so we change n to 75. A1 is the first term, which we can see over here. The first term is 3. And D is the number that you're adding to get to the next number. So how do we go from 3 to 8? And by the way, we know it's an arithmetic sequence because they told us that, right? So how do you go from 3 to 8? Well, you'd have to add negative 11. So D is actually 11. N is 75. And so all we have to do is just simplify. 75 minus 1 is 74. And don't be afraid to use your calculator if you need to. 11 times 74 is 814. And 3 minus 814 is negative 811. So if you got that right, excellent. So if you keep counting 1, 2, 3, 4, 5, all the way to the 75th term, the 75th term is going to be that. All right. So let's try number 9. Go ahead and attempt number 9. When you come back, we'll do it together. All right, we're back. So we need to change this expression to m plus negative 2 to the 5th. And then we can use our formula. Now remember, we start by raising m to the 5th power. So we have m to the 5th power, and then we're going to have m to the 4th, and then we're going to have m to the 3rd, and then m to the 2nd, and then m to the 1st, and then m to the 0. Then you're going to use the other number, this number here, and you're going to start going in the opposite direction. We're going to start at 0 power, and then we're going to go to the 1st power, and notice I have to use parentheses. You must use parentheses when you're dealing with a negative raised to some power. If you don't, then you're writing the wrong expression. Even if you get the right answer, it's still wrong, because you're writing an expression that's not correct. Okay, so then we need to write our combinatorics expressions. Remember, we start with, we write 5 at the top because we're raising to the 5th power. And we're going to start with 5, choose 0, then 5, choose 1, and the choose is just going to go up by 1 as we go along here. So this is all review. You've done this before. And I know it's kind of a pain to have to fit all this stuff in here, but then we have 5, choose 4. The hardest part is really just fitting all this stuff. And move this over a little bit. And then we're going to have 5, choose 5. So we have to write plus signs in between all of these expressions. And let's double check everything to make sure that we didn't mess up. So we've got that term. We've got that term. We've got that term. We've got this term. We've got this term. And then we've got this term. So does that look correct? Looks correct to me. Very easy to make a mistake on this stuff, so take your time and double check your work. So 5 choose 0. Remember, we pronounce this 5 choose 1 or 5 choose 0. It's just a different way to pronounce that. That's the same thing as C 5 comma 0. It's also the same thing as 5C0, like this. These are the same types of expressions that we get from there. So 5 choose 0, that notation all means the same thing. So 5 choose 0 actually doesn't mean anything. How many ways can you choose 0 things out of 5? Well, that's just defined to be 1. Again, it's a definition. It doesn't really have any direct meaning. Mathematicians just define that to be 1 for convenience. Negative 2 to the 0 power, that's 1. 5, choose 1. How many ways can you choose one thing out of 5? Well, that's going to be 5, obviously. Negative 2 to the 1 to the first power is negative 2. How many ways can you choose 5 things? Or excuse me, how many ways can you choose 2 things out of 5? So if you have a TI-84 plus, if you have a TI-84 plus, then you're going to enter 5, then you're going to push the math button at the upper left, then you're going to use the right arrow key to go to PRB, and then go down to NCR and press enter, then press 2. So you should have 5, NCR, then 2. Then you press enter and you should get 10. Okay, so that's 10. Negative 2 to the second power is 4. And then calculate 5 choose 3. So enter 5, then the math button and your TI-84 plus at the upper left, right arrow key to PRB, down to number 3, NCR, press enter, then press 3, and then enter. So again, you should have 5, NCR, 3 when you press enter, and you should get 10. So we have 10 m squared times negative 2 to the third power, which is negative 8. And then 5 choose 4. You can do that in a calculator, but that's just going to be 5. And then m in negative 2 to the fourth power is 16. And 5, how many ways can you choose 5 things out of 5? Well, that's obviously 1. M to the 0 power, anything raised to 0 power is just 1. And negative 2 to the fifth power is negative 32. So now we just have to clean up this expression. So we get m to the fifth minus 10 m to the fourth plus 40 m to the third plus 10, actually minus 80 m to the second plus 80 m minus 32. So we expanded the expression using the binomial theorem. So if you got that right, excellent. Okay, find the sum. See what you can do on number 10, and when you come back, we'll do it together. Okay, we're back. So there's a lot of terms here, so we're going to have to use a formula because this is just too long. But we need to see what type of series this is. So we need to start by plugging in 0, then 1, then 2, then 3, and so on and so forth. And so what we get is 0 plus 2 plus 4 plus 6. So what kind of series is this? Well, it's arithmetic because you're adding 2 each time. So now that we know that it's an arithmetic series, we can use our formula for the sum of the first n terms of an arithmetic sequence. Okay, so our formula, and you have to have these formulas memorized. If you don't have them memorized, then you're not going to be able to do anything on the test. You're not allowed to have a cheat sheet on the test. You have to have these memorized. I know it's difficult to force yourself to do that, but you can do that very easily. It's not difficult, so don't make a big thing out of it. Okay, so now here's where we can potentially get into some problems. If we consider 2 to be the first term, then there's going to be 93 terms total. But if we consider 0 to be the first term, then there's going to be 94 terms total. So which one should we do? Well, it just depends on what, I mean, you can do it any way you want as long as you fill out the formula properly. So if 0 is the first term, then we plug in 0 for a, but n is going to be 94. So we'd have to plug in 94. But if 2 is the first term, then we plug in 2 for a, but n is not going to be 94, it's going to be 93. So you have to use the formula properly. So which one should we do? I don't know. I'm just going to make this the first term. So then we're finding the sum of 94 terms. N is 94. 0 is the first term. The common difference is 2. 94 is n. And so 94 divided by 2 is 47. And then we get 0 plus 2 times 93. And you don't have to show every single step of this if you can do a lot of it in your head. 2 times 93 is 186. And feel free to use your calculator. You don't have to do this in your head or on paper. So we get 8,742, and that's it. So we had to use this formula because there were so many terms. We didn't want to add up all the terms one by one. So if you got that right, excellent. So we added 94 terms with 0 being the first term, and we got our sum. Now again, you'll get the same answer if you add up 93 terms and make n 93 and make 2 the first term. You'll get the same number. You just have to fill out the formula differently. Okay, so why don't you try number 11, and when you come back we'll do it together. Okay, we're back. So how many students like pizza but not tacos? So what you do is you take the 19 students that like pizza and you subtract the 12 that like both pizza and tacos, and we get 7. So 7 students. 7 students like pizza but not tacos. Okay, how many students like tacos but not pizza? So you take the number of students that like tacos and you subtract the number of students that like both pizza and tacos, and you get the number that we're looking for. How many students like either pizza or tacos? So this is the part where we need to start filling out the Venn diagram. So we got pizza and tacos, and 12 of the students liked both And we found that 7 students like pizza but not tacos, and 18 like tacos but not pizza. And so if you want to figure out how many students like either pizza or tacos, we just add those numbers. 7 plus 12 plus 18 is 37 students. Okay, how many students like neither pizza nor tacos? So there's 37 that like either pizza or tacos, and we just have to subtract that from the total number of students. So we get 7 students that like neither pizza nor tacos. Okay. So now we move on to probability. What is the probability that a randomly selected student will like pizza? Well, that's easy. You just take the number of students that like pizza, 19 of them, and divide by the total, 44. What is the probability that a randomly selected student will like neither pizza nor tacos? Well, you just take the number of students that didn't like either, and then you divide by the total number of students. What is the probability that a randomly selected student will like both pizza and tacos? Well, that's 12. That's the middle part there, and divide by 44. We can divide both sides of the fraction by 4, and we get 3 over 11. What is the probability that a randomly selected student will like either pizza or tacos? So we have the number of students that like either or, and then divide by 47 again. So if you got those right, excellent. Okay, on to number 12, part 1 of number 12. See if you can do part 1. When you come back, we'll do it together. Okay, we're back. So we need to use our sum formula for a geometric sequence. This is the sum of the first n terms of a geometric sequence, and we have 37 terms. Now the first term is obviously 1/2. We can see that there. And r. Now r is kind of difficult to see. We're told that this is a geometric sequence, so we know it is. But it's not really easy to see r. We know that if we multiply 1/2 by our r value, then we should get the next number, which is -1/3. So there's a lot of different ways to solve this. We could just multiply both sides by 2. That's the easiest way to do it. And we see that r is -2/3. So I'm going to color that differently. You don't really have to use different colors, but so we have -2/3 is r, raising to the n power, and n is 37. 1 minus -2/3. So the sum of the first 37 terms is equal to 1/2 times. Now, when you raise this -2/3 to an odd power, odd being 37, it's going to make this whole yellow expression a negative number. And when you subtract a negative number, it becomes a positive. So you could just change that to plus. Now, you can leave it like this. I don't really care. But if you see an answer in a textbook, it's probably going to be written with a plus sign. Very confusing. Now, this is obviously a double negative, so that becomes 1 plus 2/3. And then we get 1 1/2 times 1 plus 2 over 3 to the 37th power over 5/3. So there's kind of a lot of complicated math going on here. If you can do this in your head quickly, go ahead and do it. I'm doing it by steps because I don't, I want students to see what is happening here, but when you multiply fractions, you just multiply straight across. So we're going to multiply 1 by all that, and we're going to multiply 2 by all that. So 2 times 5/3 is 10/3. Okay, so I'm going to find some more room here. And so now we're dealing with a complex fraction. A lot of different ways to deal with this complex fraction. A lot of different approaches. So there's not just one way to do it, but probably the easiest way for students is to treat the division symbol like, treat the fraction symbol like a division symbol. So we turn that into that. And so then it just becomes times 3/10. I know it's kind of tedious having to do all this, but you want to write it in the simplest form possible. So the sum of the first 37 terms is 3 times all of this. You don't really have to distribute. It's not going to really accomplish much. All over 10. And that's about as simple as I would make you write that. We don't want a complex fraction. You never want to leave your answer as a complex fraction, even though technically this is a complex fraction, but you can't really simplify that very easily, so we're just going to leave that. Now this number here is very small. That number is so small that it would probably be very, very close to 0. But technically it's part of the expression, so we're leaving that in there. Okay, so if you got that right, excellent. If you got a different form, that's fine. But just be aware that your answer that you're given in, that the answer that I'm going to give you is going to be something more like that, so you want to verify that you got the right answer. Okay, go ahead and try part 2 of this problem, and when you come back, we'll do it together. Okay, so now we're looking for the 41st term of a geometric sequence. So we have to use our formula. This is a formula that you're going to have to memorize, whether you want to or not. We're looking for the 41st term. We need the first term, which is -1/2. Then we need r, the number that you're multiplying, and it's pretty easy to see that we're multiplying by 4. Multiply this by 4, then multiply this by 4, 4, so on and so forth. So r is 4, and n is 41. So the 41st term is -1/2 times 4 to the 40th power, and you could change the form of this, but it wouldn't really be much simpler, so we're just going to leave it like that. 4 to the 40th power is such a big number that we don't really even want to write that. So notice here it says you can leave your answer in an exponential form if it's very large or very small. So go ahead and try number 13, and when you come back, we'll do it together. Okay, we're back. So we can see the vertex just by looking at this. The vertex is 2, 4. 2, 4. So 1, 2, 1, 2, 3, 4. And because the expression with y is squared, we know it's going to be a parabola opening to the left or to the right. And because this coefficient here is negative, we know the parabola is going to be opening to the left. So it says write the coordinates of the focus and the equation of the directrix. We can do that after getting a rough idea of what the parabola looks like. So let's try plugging in y values. Now we're going to try to plug in y first, because if we try to plug in x, it's going to be hard to find an easy number to deal with. So let's try plugging in y is equal to 3. So 3 minus 4 is -1. -1 squared is 1. 1 times -2 is -2. Add 2 to both sides, and we get 0. So if y is equal to 3, then x is equal to 0. So that means that's a point on the parabola. And we can use symmetry. So we can mark this point also. And let's try y equals 2. 2 minus 4 is -2. -2 squared is 4. 4 times -2 is -8. And then plus 2 is -6. So there's another point. 1, 2, 1, 2, 3, 4, 5, 6, -6. And of course we can use symmetry again. So looks like that's our parabola. And remember, you want to try to avoid a pointed end here. That's supposed to look like a curve. I know it's hard to make it look like a curve, but that's roughly what it should look like. So now we have to write the coordinates of the focus. And remember, we use this formula. 1 is equal to 4 over a. P is equal to 4 over a. And a is equal to -2. That's this number here. So P is equal to -1/8. So what that means is that the distance from the vertex to the directrix line is one-eighth of a unit. So that means that our vertex, or excuse me, our directrix is going to be somewhere around here to the right of the vertex, and our focus, which I'll draw in pink, is going to be right next to the vertex. And the coordinates of the focus are going to be 1 7/8, comma 4. Because we know that the coordinates of the vertex are 2, 4. So if you move 1/8 unit this way from the vertex, then you're going to subtract 1/8 from 2. And it says here we want to write the equation of the directrix. Should probably write the coordinates of the focus over here, just so we know that we have that. It's probably okay to write it on the graph. That's fine. But the equation of the directrix, we don't really have to graph the directrix, but we do need the equation. The equation is x is equal to 2 1/8. So it's a vertical line. So we graphed the equation, we wrote the coordinates of the focus and the equation of the directrix. So if you got that right, excellent. Okay, on to the next problem here. There are 24 letters in the Korean alphabet. How many outcome variations are there for a 4-letter code if no letter can be used more than once? Go ahead and try number 14. When you come back, we'll do it together. Okay, we're back. So this is going to be P24, 4, which is also notated as 24P4. You can do this in your calculator, but if you push the math button at the upper left on your TI-84 Plus, and then the right arrow key to the PRB, and then go down to number 2, you see you have an NPR. So if you enter 24 and then you push the math button at the upper left, and then the right arrow key to PRB, and then down to number 2, and press enter on number 2, you should have this. And then enter 4, and then press enter, and you've got your answer. But you don't really have to do that. You can just understand that you have 24 options for the first letter, and because you're not using letters more than once, you have 23 options for the next letter, and then 22, and then 21. That's going to give you your answer. So this is using the multiplication principle. If you have a certain number of options and 4 choices, certain number of 4 choices and a certain number of options for each choice, you just multiply. So remember, we drew that tree diagram. That explains why this works. We're just using the multiplication principle, and we have 24 options for the first choice, 23 options for the second choice, 22 options for the third, and so on and so forth. So you should have gotten 255,024 outcome variations. So let's go ahead and write that. If you got that one right, good. Okay, it says here, write an equation of the nth term of the sequence below in recursive form. Show the value of the first term. So let's show the first term is equal to 1, and any term can be found by taking the previous term and multiplying by 5/3. So there you go. Now, how did we find this 5/3? A lot of students may have some trouble with that. Well, if we take this term and divide by 5/3, we get the previous term. And if we take this term and divide by 5/3, we get, again, the previous term. So you can see it's a geometric sequence. Okay, so if you got that right, excellent. Alright, so on to the next problem. Try number 15. When you come back, we'll do it together. Okay, we're back. So let's write this out. You don't have to write all this out if you don't want to, but I'm going to write it out just so we can see what's going on here. Just helps us to visualize. Well, the problem is it takes longer to solve the problem, so so we're looking for this term, the ninth term. We're given the second term. The second term is 10. And the seventh term is 40. So that is the information we're given. We're given this information here, and we're asked to find the blue information. So also we know it's an arithmetic sequence. So if it's an arithmetic sequence, then that means to find the third term, you would add the common difference. Now, we don't know what the common difference is, so we'll just put plus d. To find the fourth term, you add the common difference again. So now you've got 10 plus 2d. And so on and so forth. 10 plus 3d. 10 plus 4d. And that means that 40 would be equal to 10 plus 5d. So now you make an equation. I'm going to find some more room here. So you make an equation. We have 40 is equal to 10 plus 5d. And if you solve for d, you get 6. So the common difference is 6. So now that we have the common difference, we can easily find the ninth term, because we know the seventh term is 40, right? So let's write down here, seventh term is 40. And the eighth term is 40 plus 6, and the ninth term is 40 plus 6 plus 6, which is 52. So this is just one way to show your work. You really don't have to show much of this. So if you can do that, a lot of that in your head, that's fine. It'd be nice if you wrote something down just to show that you did something. But anyway, that's the so that's the explanation. Okay, try number 16. There's two parts to number 16. When you come back, we'll do it together. Okay, so this is a geometric sequence, because we can see that we're just dividing by 4. Now if you don't see that, you can use your calculator. You can just take this number and divide by this number, and you'll get 1/4. And if you take this number and divide by this number, you get 1/4 also. So it's a geometric sequence. So now we're going to find an expression for the nth term. Since it's geometric, the formula for the nth term is that formula there. And the first term is 0.8, and the common difference is 1/4. That's what we're multiplying. Dividing by 4 is the same thing as multiplying by 1/4. And we could change this a little bit, but it's not really necessary. Now sometimes, well, it's more common to see the nth term in braces, so we're just going to put it in braces. We don't really need to do that, but that's the most common form that you'll see. So if you got that right, excellent. This is neither arithmetic or geometric. It has nothing to do with an arithmetic sequence or a geometric sequence. Now the inner part here is actually arithmetic, but because you're putting it in a cosine function, it doesn't have any meaning. So that's not geometric or arithmetic. So how do we write this? Well, we're assuming that n produces the first term. So notice it says that up here. So if you plug in 1 for n, you should get 3. And if you plug in 2 for n, you should get 4. And if you plug in 3 for n, you should get 5. So there you go. There's an expression for the nth term. Okay, so why don't you try number 17. 17 is the same problem. When you come back, we'll do it together. Alright, we're back. This is neither arithmetic or geometric. Either arithmetic nor geometric. And see what we can do to find the nth term. It's going to be log base 2 of n plus 17 because we have to plug in 1 for n for the first term. So there you go. If you got that right, excellent. This is arithmetic. And what is the nth term? Well, let's use our formula for the nth term of an arithmetic sequence. The first term is negative 11. D is, looks like we're adding 21 each time. And so all we have to do is just simplify this as much as we can. You could leave it like this, but it's probably better to put it in a simpler form. And negative 11 minus 21 is negative 32. So we have negative 32 plus 21n. And so that's it. Now we could write it in braces because that's the more common way to write it. So if you got that right, excellent. Okay, try number 18. When you come back, we'll do it together. Alright, we're back. So this is a binomial theorem problem. So remember, you take the first term and you raise it to whatever power the binomial is being raised to. Then you take the first term and raise it to the next power, then 7, and then 6. We're only interested in the x to the 6th term, so we can stop at that point. So then we need to take the other number in the binomial, 3, and go in the other direction. 3 to the 0, 3 to the first power, 3 to the second power, 3 to the third power. And we would just keep adding more and more terms until we get to the last term. We don't have to write all the terms, obviously, because we're only interested in this term here. You don't really have to write any of these terms, to be honest with you. I'm just giving you a feel for what the expression would look like. So then we start with, we always write 9 and then choose 0, and then 9, choose 1, and what you're choosing just keeps progressing. 9, choose 3, and of course we write addition signs between these expressions. So let's double check and make sure we did all that correctly. Looks like we did it correctly. So again, we're interested in this term here. So we can, at this point, we can ignore all the other stuff. And so we need to find 9, choose 3. So you're going to enter 9 into your TI-84 Plus, then the math button at the upper left, then the right arrow key to the PRB, and then down arrow key to the NCR, and then 3. So you should see this in your calculator. Press enter and you get 84. So 84 times 2x to the 6th power is 64x to the 6th power. 3 to the 3rd power is 27. So we're going to get a pretty big number here. 84 times 64 and then times 27. So we have 145,152 x to the 6th. So the problem is asking what is the coefficient of the x to the 6th term. So that is that large number. So 145,152. All right, if you got that right, excellent. Okay, on to the next problem. Johnny has a rock collection. 4 of his rocks are basalt, 5 of them are limestone, 6 of them are quartz. He chooses 3 of his rocks at random to show his class at school. So go ahead and try number 19. When you come back, we'll do it together. Okay, we're back. So we want to find the probability that all 3 of the rocks that he chooses at random are basalt. Now, we're going to count all the different ways that he can choose 3 rocks. So that's going to be the number of ways you can choose 3 things out of 15. And of course we don't care about the permutations, because if he chooses a basalt rock and then a quartz rock and a limestone rock, that's the same thing as switching those letters around. You know, these are the same. So we don't care about permutations. That's why we're writing C for combinations. Now, that's every single option that is possible, and we're assuming that each one of these outcomes is equally likely. There's no reason to believe that they're not, because it says they're chosen at random. Now we're trying to figure out, I mean, the outcome that we're considering is we get 3 basalt rocks. So how many different ways is that outcome? How many different ways does that outcome appear? Well, we're going to choose 4 basalt, or we're going to choose 3 basalt rocks out of a total of 4. So there you go. So we can enter this into our calculator, and we get, we want to press 4, then the math button at the upper left, then the right arrow key to PRB, then down arrow key to NCR, then enter 3, and you get 4. So then 15, the math button at the upper left, the right arrow key to PRB, the down arrow key to NCR, enter, and then press 3, and then enter, and we get 455. And that fraction cannot be reduced. So there you go. So I know that problem isn't exactly easy, but it just tells you that probability, like I said, it can get out of hand. So now we're going to calculate the probability of 2 quartz rocks and 1 basalt rock. Again, if he's choosing these combinations at random. So the sample space again is 15, choose 3. But now he's going to choose 2 rocks that are quartz out of a total of 6 quartz. So how many ways can you choose 2 quartz rocks out of 6. And for each one of those possibilities, each one of those outcome variations, you have the number of ways that you can choose 1 basalt rock out of 4. So we're multiplying, we're using the multiplication principle. So these are all, you have two choices to make. What combination of quartz rocks are you going to choose, and what combinations of basalt rocks are you going to choose? So you have this many options for the quartz rocks and this many options for the basalt rocks, and you multiply them all together. Remember, that's like choosing a sandwich. You have certain type of meat, you have certain type of bread, and you have certain type of cheese. You take each option and you multiply them all together. That's the multiplication rule. So we're going to go to the calculator. If you have a TI-84 plus, that's an if, then you press 6, then the math button at the upper left, right arrow key to PRB, down arrow key to NCR, then enter 2, then enter, and you have 15. 4 choose 1 is 4, of course. 15 choose 3, we already calculated that, is 455. We know we can divide this by 5, and we know we can divide 15 by 5. So you're going to get 3 here, multiply it by 4, you get 12. And when you multiply 455 by 5, you get 91. So that's as far as you can go with that. So if you got that right, excellent. This is a very challenging problem, and I know, but I just remember I warned you that probability problems can get out of hand. Okay, part 3. What is the probability that 2 will be basalt and 1 will be limestone? So probability that 2 are basalt and 1 will be limestone. So the sample space is the same number. So the probability that 2 will be basalt is the ways that you can choose 2 things out of 4, because there's 4 basalt rocks total, times the number of ways that you can choose 1 thing out of 5, because there are 5 basalt rocks. So we're going to enter 4, the math button, right arrow key to PRB, down to NCR, then 2, then enter. We get 6 times 5 over 455. We know we can divide both sides by 5, and we get 6 over 91. So if you got that right, excellent. Okay. So now, what is the probability that 1 rock will be basalt and the other rock, another rock will be quartz, and another rock will be limestone? So again, the sample space, the number of total outcomes, is the way that you can the number of ways you can choose 3 things out of 15. But the number of ways that you can choose 1 basalt rock out of 4 is 4 choose 1. The number of ways you can choose 1 limestone rock out of 5 is 5 choose 1. And the number of ways you can choose 1 quartz rock out of 6 is 6 choose 1. So this is just a way to calculate these things. It's a scary way, but it is a way nonetheless. So we know we can divide both sides by 5, so we're left with 24 over 91. If you got that right, excellent. Okay, so a fish is chosen at random from a tide pool. The probability that the fish will be a minnow is 18%. The probability that the fish will be a mackerel is 8%. What is the probability that the fish will be either a minnow or a mackerel? Try number 20. When you come back, we'll do it together. Okay, we're back. So the probability that the fish will be either a minnow or a mackerel is equal to the probability that the fish will be a minnow plus the probability that the fish will be a mackerel. Now, how do I know this? Well, because these are mutually exclusive events. If you're going to randomly choose one fish and one fish only, because it says a fish, a fish is chosen, so you're only choosing one. You can't choose both. So they're mutually exclusive events. And because they're mutually exclusive, you can just add the probabilities. And remember, when you're using probability, or when you're using percentages in calculations, you always have to change to decimal form. Whoops, that should be a 0.08. Don't make that mistake. That should be 0.08. So then we get 0.26. So that's the answer to that problem. I'm going to bring that down a little bit. So that was pretty easy. Okay, so if you got that right, excellent. Try number 21. When you come back, we'll do it together. Okay, we're back. So we can use the complement rule. The probability that the football team will win is equal to 1 minus the probability that the football team will not win. So they told us the probability that the football team will win is 0.73. So now we just have to do a little algebra. I used a capital W, so I probably should use a capital W everywhere. We can just do a little algebra, but you know it's just going to be 1 minus 0.73. You can put this on the left side of the equation, or you can subtract 1. Then you would get negative 0.27 is equal to negative probability of not winning. Divide both sides by -1, and you have the probability of not winning the football game is equal to 0.27. So you got that right? Excellent. Okay, so try number 22. When you come back, we'll do it together. Alright, we're back. 5 children are asked to state their favorite character in a comic book. There are 7 characters in the comic book. How many outcome variations are possible? So, how many outcomes are possible for the first child? Well, he's got 7 characters to choose from. For each one of those possibilities, you have the second child choosing his favorite character. There's 7 possibilities for that, because you can have repetition and so on and so forth. So really the answer is 7 to the 5th power. So 7 to the 5th is 16,807 outcome variations. So I believe we talked about this scenario in part 1 of my counting. We had 2 classes on counting, I believe, and it was part 1, the first class. So we are allowed repetition. and the permutations matter. For example, the first kid could choose Superman, and the second kid could choose Lex Luthor, I guess. But then you can also have the first kid choosing Lex Luthor and the second kid choosing Superman. See, the order matters. And we can also have repetition. You can choose Superman, but you can choose Superman again, and you can choose Superman again. So in that situation, it's just 7 times 7 times 7 times 7 times 7. So if you got that right, excellent. Okay, so let's go on to number 23. It says here that Sarah has 108 coins. 22 of the coins are made of silver, and 56 of them are quarters. 67 of the coins are either quarters or made of silver. So it may be helpful for you to understand that in the past, in the United States, quarters were made of silver. Today they're not made of silver. So it's possible to have some quarters that are made of silver and other quarters that are not made of silver. So go ahead and try number 23, and when you come back we'll do it together. Okay, we're back. So there's a total of 108 coins, and we know that 67 of the coins are either quarters, because you can have pennies, dimes, quarters, silver dollars, all kinds of things. But we want to know how many of these coins are not made of silver and they're not quarters. So we take the total number, which is 108, and subtract the number of the coins that are either quarters or made of silver, and we get 41. So there's 41 coins that are not quarters and they're not made of silver. So now it wants to know how many coins are silver quarters. So that means how many coins are both made of silver and quarters. So over here I'm going to write S for silver and Q for quarter, and I'm going to write 41 outside here because that represents all of the coins that are neither. So for this I need to use an equation. The number of coins that are either made of silver or quarters is equal to the number of coins that are made of silver plus the number of coins that are quarters minus the number of coins that are both made of silver and are quarters. And I'm going to solve for this. This is what we're looking for. Now in this problem, they tell us that 22 of the coins are made of silver. So we know that number. We're also told that 67 of the coins are either quarters or made of silver. So that's this part here. So that's 67. And we're told that 56 of the coins are quarters. So you don't have to use colors like this. Obviously this takes a while to do this. I'm just doing this for your benefit. Okay, and so we're solving for the number of coins that are both made of silver and are quarters. So we need to add 22 and 56, and then we get 78. And 67 minus 78 is negative 11. And then if we multiply both sides of the equation by -1, we see that the number of coins that are both made of silver and quarters is 11. So that's a very important piece of information. So that allows us to write 11 in there. And now we want to know how many coins are quarters, but they're not made of silver. So that's this purple region in here. So what we do is we take the number of coins that are quarters, which is 56, and we just subtract 11. So that would be 45. So 56 minus 11 is 45. 45 coins. And by the way, we have to write coins here and rectangle that. That was an answer for part 2. Okay, and then how many coins are made of silver but are not quarters? So that's this orange region in here. So we take the number of coins that are made of silver and we subtract 11. So 22 minus 11 is equal to 11. So 11 coins are made of silver, but they're not quarters. So if you got that right, excellent. Okay, so on to the next problem. Go ahead and try number 24. When you come back, we'll do it together. Okay, we're back. So we have 4 choices to make. Each choice has a certain number of options. So we're going to use the multiplication principle to multiply all the different options, and that'll give us the number of outcome variations. So we're using the multiplication principle. But how do we figure out how many options are in each choice? Well, we have to use combinatorics, combinations. We have to count combinations. So this is the first choice. I meant to write that word to the right of the number. Doesn't really matter, but I don't want to confuse people. So first we have to choose the team of doctors. So there's all kinds of different options for the team of doctors. We have 7 doctors, but we're only going to take 4. So the first choice is, the number of options in the first choice is the number of ways you can choose 4 doctors out of 7. And then of course you want to choose 6 nurses out of 10 that are available. And then you want to choose 2 scientists out of 3 that are available. And then you want to choose 3 volunteers out of the 6 that are available. So you can do this in your calculator. We've done it many times. If you're using a TI-84 Plus, you should know how to do this by now. So we have 35 times 210 times 3 times 20 and If we multiply all those numbers, we get 441,000. So we have 441,000 outcome variations, or we could say 441,000 different teams. Probably better to just say outcome variations. So if you got that right, excellent. Okay, let's go on to the next problem. Go and attempt number 25, and when you come back, we'll do it together. Okay, we're back. So I'm going to label these circles coffee shop, deli, and B for bakery. Now we're told that 8 of the supermarkets have none of these features, so I can put 8. I can put 8 outside the circles, and we're told that 12 of them have all 3. So notice that we are kind of working backwards. We're starting from this part of the problem and going backwards. So now let's start with this information here. 30 have a bakery and a deli. So this region here, this purple region, has to have a total of 30 supermarkets in there. So 30 minus 12 is 18. So this number would be 18. Okay, so let's now go to this information here. 34 supermarkets have a coffee shop and a deli. 34 supermarkets have a coffee shop and a deli. So that's this region here. So there should be 34 supermarkets. So we have to subtract 12 from 34, and we get 22. So there's 22 supermarkets that have, well, 22 goes in that region there. And then we're told that 26 supermarkets have a coffee shop and a bakery. So that's this region here. It should be a total of 26 supermarkets. So 26 minus 12 is 14. Okay, so now we can go up to this information here. It says 68 supermarkets have a coffee shop inside them. So this whole circle should be 68 total supermarkets. So we're going to take our number 68 and subtract 22. Then we're going to subtract 12. And we're going to subtract 14. And we get 20. So 20 supermarkets have a coffee shop, but they don't have a deli or a bakery. So then we're going to go to this information. 55 supermarkets have a deli inside them. So this circle here should be a total of 55 supermarkets. So 55 minus 22 minus 12 minus 18 is 3. So there's only 3 supermarkets that have a deli but not a coffee shop or a bakery. And at this point, I think we're ready to answer our question. So we want to know how many supermarkets have a bakery but no coffee shop or deli. So that's this region here. That's what we're looking for. So the answer is going to be the total number of supermarkets minus the number of supermarkets that don't have any, minus all these other numbers. And whatever that ends up being, that's going to be our answer. So 101 minus 8 minus 20 minus 22 minus 12 minus 14 minus 3 minus 18, and we get 4. So there's 4 supermarkets that have a bakery, but they don't have a deli or a coffee shop. So we want to say 4 supermarkets. So if you got that right, excellent. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2, number 3 and 4 and 5, 6, 7, 8, and don't go before you get your homework. Remember, the homework is a practice test. Don't take the test in the next class unless you do this practice test for homework. So here's screenshot number 1 of the homework, and number 2, and number 3, and number 4, number 5, number 6, number 7, and number 8. But don't go before you get the answers. Remember, it's not enough just to attempt the practice test. It has to be done correctly, so you have to check your answers. Here's the answers for the practice test for your homework. Practice test version 2. And here's the rest of the answers. So get that homework done. Get that practice test done completely, correctly, and neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.